So denominator already the same. Just do the work up top. Like terms. That's the name of that game. So let's say we had 2x plus 2 over x plus 2 plus 2 over x plus 2. A lot of 2's in there. Is the denominator already the same? Yes. The denominator is already the same. You do the operation with the top. So on the top, we're adding 2x plus 2 plus another 2. What's that going to give us on the numerator? 2x plus 4. So combining like terms there. Now we look to simplify because we always got to reduce fractions if they will. Okay? So will the numerator factor any?
Yeah.
How? Take a 2 out. So the GCF of a 2. What's that leave in the parentheses? X plus 2, which happens to be the same thing that's on the bottom. So what happens to those? They cancel out. All that's left is 2. Always going to look to reduce if possible because that's what you do with regular fractions. With numbers, polynomials are no different. You're going to look to simplify at the end. Take another one. Say we had 4x over x minus 3 minus 12 over x minus 3. Denominator's already the same. If the denominator's already the same, we just do the operation with the top. So we end up with 4x minus 12 over x minus 3. Will that reduce any? How? 4 out of the top, leave you x minus 3, x minus 3 on the bottom. They cancel one another out. Excuse me, thank you. And that's just going to be 4. All right, 16x squared over 4x plus 5 minus 25 over 4x plus 5. Denominator's already the same, right? That's nice when that happens because that means it's just the numerators that we're working with. Will the numerator or the denominator factor? How will the numerator factor? 16 and 25 don't have a GCF. But 16x squared minus 25 is a what? Difference of squares. 4x minus 5, 4x plus 5. What cancels? Yeah, the 4x plus 5s. We're seeing denominator already the same. Work the numerators and then look to reduce. Okay, always got to look to reduce. Okay. And so when we're reducing, all of those methods of factoring can come into play. So you got to be careful of that. Pretty simple one to start off with. 3 over 7 plus 5 over x squared. Are the denominators the same? No. Okay, so what we want to do is we want to find the least common denominator. And what you've got to do with the least, when you're trying to find least common denominator, is first look at the denominators of each fraction individually and decide if they will factor. Okay? Well, 7 obviously doesn't do anything. X squared doesn't do anything. This is a pretty simple problem, okay? If they will factor, then we've got to look and see if they have any factors in common. These two don't have any factors in common, okay? So the least common denominator would be the product of the two. So our LCD here is going to be 7x squared. Just multiply them together. If they don't have anything in common, just multiply them together, okay? Now, your job then to fix the fractions so that you can add them is to make the denominator 7x squared on each one. What does this one need? It needs the x squared. So I'm going to multiply the bottom times x squared and the top times x squared. That's 3x squared over 7x squared. Bless you. Bless you again. What does this fraction need? 7. So I'm multiplying bottom times 7, top times 7. 35 over 7x squared. Now it's a problem like we just got through doing. The denominators are the same. So we're going to add the numerators. Are those like terms? No. So it's just going to be 3x squared plus 35 over 7x squared. The next step would be to try to simplify. So will that numerator factor in? 3 and 35. Have anything in common, do they? So since that won't factor and it doesn't match what's in the denominator, you're done. That's the answer. Let's kind of step it up a little bit here. Let's say we had 8 over x times x plus 2 plus 9 over x. Okay, so two fractions. You got one that has x times x plus 2 on the bottom, the other one that just has x. Okay. When we look at a problem like that, we try to find the least common denominator. That's our job. Okay, so the first thing you want to look at is, well, they've already got this one factored for us. That's good. That's kind of a step ahead. This one doesn't factor anyway. Then we look at the factors and decide, are there any that are the same? Well, I got an x, and this is x, right? If they're a matching piece, then they're part of the least common denominator. Okay, so the first part of the least common denominator is the matching factor. Matching factor is x. Then the next part of the least common denominator are any factors that don't match. Okay, well, what factor doesn't match? The x plus 2 doesn't match, right? So it has to be part of the least common denominator because it's got to be in there because it's in this denominator. Okay, so we get the matching piece and then any that don't match. Okay, notice that we only have one x. There's one x on each of those. So there's only one representative from that factor for each one. Okay, so we got x times x plus 2. Does this denominator need anything? What does this one need? It needs x plus 2. So we're going to multiply times x plus 2 on the bottom and x plus 2 on the top. This one stays the same. It's 8 over x plus 2. The top part of this one, what are we going to do? Distribute 9x plus 18 over x plus 2. Add them together. 9x plus 18 plus 8 would be 26. The next step, the last thing you want to do after you've done that is see if the numerator will factor. The 9 and 26 have anything in common? No, if it were 9 and 27, yeah, maybe, but doesn't have anything in common, so we're going to leave it like that. That's our final answer. I don't require you to multiply the denominator back out. It doesn't help you any to do that. So leave it in factored form there. Save yourself a little work. Let's see here. Let's do 7x over x squared plus 3x minus 3 over x plus 3. So we're kind of starting to ease into the ones that are a little bit more work to them. So this h is a lot like g. It's just not got that step already done for you. So first thing you want to look for when you're trying to add or subtract rational expressions is the denominators and see if any of the denominators will factor. Every one we've had so far, you didn't need to do that with because they were either already factored for you or they didn't factor. So will this factor? X squared plus 3x. Bring an x out. It's got a GCF of an x. So this is really x parentheses x plus 3. Okay. So we've factored the GCF out of that. Now we look for the LCD because the other fraction, the denominator, won't factor. If it would factor, we'd need to factor it too. Okay, you want to factor your denominators as much as possible. Okay. Now, what is the shared factor? X plus 3. What factor is not shared? X. LCD is x times x plus 3. What fraction already has that? This one, right? The first one already has x times x plus 3 as the denominator. The second one needs what? It needs an x. So I'm going to multiply bottom and top by x. So that gives us 7x over x times x plus 3 minus 3x over x times x plus 3. By multiplying both this bottom and top, numerator and denominator by x, it gives us the common denominator, and then we got a math problem to work on top. What's 7x minus 3x? 4x. Will that simplify? Ah. The x is this x up top. We'll cancel that x on the bottom. Or over x plus 3. Oops. There's the simplified version of that problem. Still on. Let's go a little deeper. 7 over 9x squared plus x over 3x squared plus 3x. First thing you want to look for are the factoring of the denominators. Okay, so 9x squared, that's a monomial. It doesn't have addition or subtraction in it, so we normally don't think about factoring it. So we go to the next one, that's 3x squared plus 3x. How does it factor? 3x is the GCF. What's that leave in the parentheses? X plus 1. All right, now, when we go to try to find our least common denominator, this one's a little bit tricky because is there any parts that go together or match up? Yeah, but it's hidden. What makes 9x squared? What could related to the factoring of the second denominator? 3x times 3x. So 9x squared, we normally don't factor that sort of thing. But it really, we know that it's 3x times 3x. All right. Now, how many 3x's match? Yeah, we can only match up 1 and 1, right? So when we look at our least common denominator, we get the 3x that matches, but then we got to get the parts that don't match. Well, there's another 3x right here. We got to use it too. And then there's an x plus 1 that's not matched. So we got to use it too. So the common denominator is 3x times x plus 1. What does this first fraction need? It doesn't need another 3x, does it? It's already got both of them. It was disguised as 9x squared, but it's got 3x times 3x. So it needs an x plus 1. So I'm going to multiply this one by x plus 1 on top and bottom. What does this second fraction need? Another 3x. So we multiply top and bottom by 3x on the second fraction. That gives us 7x plus 7 over 3x times x plus 1 plus 3x squared over 3x times x plus 1. Once we get the denominators the same, it's just adding or subtracting the numerators. That's all we're working with, okay? So 7x plus 7 plus 3x squared. Are there any like terms there? No. So we just write it in descending order. 3x squared plus 7x plus 7. I'm going to go ahead and just multiply the 3x times 3x together and get 9x squared, parentheses, x plus 1. That's the more common look to that. Now we need to try to simplify, if possible. Doesn't mean that it always will. Most of the time it doesn't, but you've got to try, okay? How do we factor the numerator? X method. So we need 3 times 7, 21. We need something that multiplies to be 21 and adds to be 7. Or is there anything that does that? 3 and 7 adds to be 10. 21 and 1 adds to be 22. That's the only things that multiply to be 21. So the numerator doesn't even factor. So we know it can't simplify. So this would be our final answer for this one. If you left the denominator like this on homework or a quiz or something, I'd be fine with that. But understand that probably on a multiple choice situation, you're probably not going to see this. You would see this instead. They are the same thing mathematically, though. All right. Let's go to one that's a little bigger. X plus 3 over x plus 4, x minus 1, minus 2x minus 5 over x plus 2, parentheses, x plus 4. All right, so kind of starting you out with a pre-factored denominator on this. It makes it a little easier to see the process for finding that least common denominator. So we got x plus 3 on the top over x plus 4 and x minus 1. And then we got a minus sign and 2x minus 5 on top over x plus 2 times x plus 4. So when we find that least common denominator, the first piece that we should write down is the one that's what? Shared between the two. Which one's the same? X plus 4. So we've got x plus 4 is already in both of them. What pieces are not in both of them? X minus 1 is not in the second one. X plus 2 is not in the first one. That tells me the first one needs what? It needs x plus 2. So the top gets multiplied by x plus 2 as well. What does the second one need? It needs the x minus 1. So we multiply top and bottom by x minus 1. Okay. So this is where the algebra gets a little longer because you got to multiply out x plus 2 times x plus 3. And so x times x is x squared plus 3x plus 2x plus 6. So that'd be x squared plus 5x plus 6. And then the denominator, I'm going to have x plus 4, x minus 1, x plus 2. It really doesn't matter what order you put that in. I'm just writing in the same order that I did over here. Doesn't matter. Okay. So this top part came from multiplying x times x to get x squared. X times 3 is 3x. 2 times x is 2x. Together, that's 5x. 3 times 2 is 6. So I just multiplied out the numerator because I'm going to have to add or subtract at the end anyway. All right. And then I'm subtracting, and I want to multiply out this numerator. 2x times x is 2x squared. 2x times minus 1 would be negative 2x. And a negative 5 would be negative 7x. And then negative 5 times negative 1 is positive 5. And then the denominator is still x plus 4, x minus 1, x plus 2. And again, it really doesn't matter what order you put the denominator in as long as it's got all the pieces from the least common denominator. All right, so this one, a little bit more work. And it's got the minus sign in the middle. So you got to be careful when you do your subtraction, because what are we subtracting from this guy? Just the 2x squared? The whole thing. So when we do that work, we're subtracting the entire polynomial. You want that there? Okay. So x squared minus 2x squared would be negative 1x squared, right? 5x minus negative 7x. What's 5 minus negative 7? Positive 12x. 6 minus 5. Positive 1. Okay. Will that numerator factor? Negative 1 times 1 is negative 1. Is there anything multiplies to be negative 1 and adds to be 12? No, there's no way that happens. So we know that that numerator doesn't factor, and we've got that as our final answer there. The key here, the mistake that most people can do, all this hard part, but they'll make a mistake here with the minus sign, and instead of subtracting each piece, they'll just subtract 2x squared and then combine the others with the wrong sign. You got to be careful. When it's a subtraction problem, you're subtracting the entire numerator, not just the first part. Okay. I'll kick it up to the next level here. X plus 1 over x squared plus 4x plus 4 minus 6 over x squared minus 4. Okay. So this one, a lot like the previous problem, but it's not factored for you. You've got to factor it on your own. Okay. So first fraction, the denominator. How does that factor? X method. So we need something that multiplies to be 4 and adds to be 4. 2 and 2. So this is x plus 2 times x plus 2. Okay. And then what does this one factor as? Difference of squares. So it would be, yep, good job. Now, when we go to find our least common denominator, how many x plus 2's are shared? There's one. There's one over here and one here. So that's the only one that's shared. So that's these two. And then, or it doesn't matter which one of these you pick. Okay. So it needs what else? An x minus 2 and another x plus 2. So if the least common denominator is x plus 2 times x plus 2 times an x minus 2, what does the first fraction need? It needs an x minus 2. What does the second fraction need? Another x plus 2. Now we take those and multiply them out. So x minus 2 times x plus 1 be x squared minus x minus 2. Over x plus 2, x plus 2, minus 2, minus 6x plus 12 over x plus 2, x plus 2, x minus 2. Simplify from there. So we're doing that subtraction in the numerator. X squared minus, are there any x squareds in the second one? No, so x squared is going to come over. Negative x minus 6x would be negative 7x. Negative 2 minus 12, negative 14. Is there anything that multiplies to be negative 14 and adds to be negative 7? No, so that doesn't factor. Again, I'm telling you, it doesn't usually simplify very much when you're doing addition and subtraction when you've got to do something to the denominators, but you've got to look for it. Okay. Now the denominator, I'm going to write it a little bit better, like higher level thinking here. How could I write this part a little shorter? I could say x plus 2 squared because there's 2 of them, just to shorten it up a little bit, and then x minus 2. Again, this denominator and this are the exact same thing. I just wrote this to shorten it up. Okay? So got to factor first, then get the matching pieces. Okay? And get that least common denominator. Fix the numerators. That's the name of the game. Okay? All right, let's look at these things called complex fractions. This is the combination of division and addition and subtraction. And what it is, it's fractions inside of fractions, is basically what it boils down to. So let's start with this one. It's not as, it looks really hard. It's not. It starts like this: 5 over x plus 4 over 1 over x plus 4 plus 2 over x. So it's a big fraction, but it's got fractions in the top part and fractions in the bottom part. So it looks like it's the hardest thing in the world, but it's really not, because the fractions that they're going to put in here are usually not that difficult. Okay. Now, what you've got to do is look for the places where there's addition or subtraction. Okay. Where's that at? It's in the denominator of this one. It won't always be in the denominator. Sometimes it'll be in the numerator. The idea is to look where there's addition and subtraction and work that part first. Okay? So if we're going to add 1 over x plus 4 plus 2 over x, what do they need to have? Common denominator, right? Just like the other addition problems we've done today. Addition and subtraction problems. So will this factor? X plus 4? No GCF? No other method for factoring that? X, does it factor? Absolutely not. Nothing at all to do. So what would the common denominator for these two fractions be? X plus 4 times x. It's the product of the two. Okay, so what does the first fraction need? It needs an x. Second fraction needs an x plus 4. Okay. The top part I'm not messing with right now. Don't worry about it. So it'd be x over x times x plus 4 plus 2x plus 8 over x times x plus 4. So this bottom part, I'm just doing the same thing we've been doing and done anything different. The top part's just there, and we ain't done anything with it yet. Okay, we're gonna simplify the bottom. Okay, x plus 2x plus 8 would be bottom part. 5 over x plus 4 equals 3x plus 8 over x times x plus 4. All right, so we have a fraction divided by a fraction. They wrote it like a big fraction, but it's a division problem. This problem, the exact same thing as we did last week when we had 5 over x plus 4 divided by 3x plus 8 over x times x plus 4. They write it like that, so it looks hard, but it's just this. How do we do this? Flip which one? Flip the second one. So 5 over x plus 4 stays here, times x plus 4 over 3x plus 8. Okay. What cancels? The x plus 4s. 5x, 3x plus 8. So when it starts out, yeah, it looks rocket science, kind of, but it's not. It's really easy stuff. It's just you've got to take it one piece at a time. Work a numerator, work a denominator, and then turn it into a division problem. Let's do another one. We had 6 over x minus 5 over 3 over x minus 2x over x minus 5. Again, this one has all the work in the denominator, but that doesn't necessarily mean that it will always be in the denominator. It could be in the numerator. What do we do first? Common denominator on the bottom would be x minus 5 times x, because this one doesn't factor, that one doesn't factor. So x times x minus 5. So the first fraction needs the x minus 5. Second fraction needs the x. That's going to get us 3x minus 15 over x minus 5 minus 2x squared over x minus 5. Simplify the bottom. Well, no like terms here on this subtraction, so it's just going to be negative 2x squared plus 3x minus 15 over x minus 5. And then the top part, 6 over x minus 5. I haven't done anything with that yet. We are about to. I would look at the numerator here and see if it would factor and multiply to be 30. and add to be positive 3. 6 and 5 doesn't do that. 10 and 3 doesn't do that. 30 and 1 definitely doesn't do that either. So that numerator doesn't factor. Okay? Always, after you do addition and subtraction, always try to simplify. It'll make things easier if you do, especially on these complex fractions. So now, that big fraction is really a what? Division problem. Which one gets flipped? This one on the bottom gets flipped, right? So we got 6 over x minus 5 times x minus 5, negative 2x squared plus 3x minus 15. What cancels? Yeah, x minus 5 cancels the x minus 5, leaving us 6x over negative 2x squared plus 3x minus 15. It simplifies out there fairly nicely. None of the complex fractions have really complicated denominators. Yeah. All right, so recapping what we're doing here, okay? When you get a complex fraction or any addition or any problem that has addition or subtraction of fractions in it, what do you have to do first? See if what will factor? The denominators. Look to factor the denominators first. Don't factor the numerators because you're going to multiply something times them anyway. So just factor the denominators. Look for the what? LCD, the least common denominator. Look for what they're going to be have in common. Okay, so you're going to factor the denominators and then get the common denominator for the fractions. Multiply out the numerators. Get something on the top, and then if it's a complex fraction, you're gonna flip the bottom and multiply and cancel out the way we did last week. Okay, I've got a few practice problems for you. For this, there's only 20 total. It's not super complicated stuff today. Practice this. Got some time in class today. And tomorrow we're going to talk about solving, which is taking this idea and just working towards solving these things. So it's a lot of the same idea. Common denominator is key. So.